In this lesson, I'm going to talk about the pieces of spheres and then get to the surface area of spheres. The first thing is just what is a sphere, and notice it says it's a locus of all points. Now, a locus is just a set of points that satisfies a certain condition. So when you look at the definition of a locus of all points in space, it's a bunch of points that are in space that are all equidistant from a given point, and that given point will be the center. So in this case, I have a sphere on the screen. That center point, or the given point from the definition, would be point D. And then we have all these different pieces that are going to be a part of the sphere. The first one that I'm going to look at is a chord. Now the chord in this picture would be that piece right there. It's a segment that has its endpoints on the sphere. The next one is going to be a great circle. Now a great circle, that's the one that's highlighted in green. A great circle is a circle on the sphere that has the same center as the sphere. Now there are going to be other circles that we can put on the sphere, but they won't have point D in this case as the center. Those are not great circles. But if the center is the same for the circle and for the sphere, we refer to it as a great circle. My next one is going to be the center that I've been talking about, all the way in there at point D. The radius, that would be the shorter pink one in here. It goes from the center to a point on the sphere. My next one is the diameter. Now that's the longer pink piece in here, the one that actually goes all the way through the center. So the endpoints of the diameter are on the sphere. It could also be referred to as a chord. It's just a special chord where it runs through the center. And then I have this one, which is called the tangent line. Now this tangent line is this red one right here. That's going to be a line that touches the sphere at only one point. And it never actually goes inside of the sphere. But it just, only touches the sphere one time, like I said. Now when you take a look at this, what's that thing? Well, that is a hemisphere. It's half the sphere. So I try to think of the globe. You have the northern and the southern hemisphere, and hopefully that will help you remember what a hemisphere is. And then calculate the surface area of the sphere. Well, there's a little formula for it, and it's not too long, and it's right there. Surface area equals 4 times pi times r squared. And kind of my little example here is you have to kind of picture this, is if you were to take an orange, cut the orange in half, and then on a piece of paper trace the orange 4 times, you're going to have 4 circles on your paper. Now when you peel the orange, that would be the surface area of all the peelings. You should be able to take, or you would be able to take all those peelings and put them into those 4 circles, and it would fill each of those 4 circles completely. So you'd have to do some cutting and making sure that they all fit, but eventually all those peels would fit into the surface area, or the area of those 4 circles. So maybe that will help you remember the little formula for the surface area of a sphere. And that's going to conclude the lesson portion on surface areas of spheres.